Okay, chapter 7. Here we go. Section 7.2, 0 and negative exponents. And it is possible, this should feel like review also. So, let us begin. I think I can get everyone to agree that something like 4 divided by 4 is equal to 1. And that basically anything divided by itself is 1. So from that, I would hope I could get you to believe that x to the n divided by x to the n must also be equal to 1. So, using the laws from the last section, if we notice we have the same bases and we're doing division here, x to the n divided by x to the n minus n, x to the n divided by x to the n has to be equal to x to the n minus n. And x to the n minus n is x to the 0, which we've already agreed that these two guys are the same. And so if this guy equals 1, then so does this. And so here you have it. Anything to the 0 power is equal to 1, except, strangely enough, 0. Because when you put a 0 to the 0 power, we get something called indeterminate form, which comes up down the road. And I just want to make one comment here, and that is, anytime your brain wants to trick you into thinking you don't know that anything to the 0 power is 1, I just propose you put anything you want into your calculator. Except my calculator is not working right now for some reason. Say 10, raise it to the 0 power, and you can reconfirm to yourself that it's 1, in case your brain's trying to trick you into thinking it's 0 or something else. So there's really no excuse for not keeping that straight. Okay, what else do I want to say? Well, I'm going to just go right on to the negative exponents. I've said enough about that. The other really important part of this section has to do with something like x to the negative n. And that is equal to 1 over x to the n. Once again, I need to just, for mathematical purposes, be clear to say that x cannot be equal to 0. Now, the language that I often use, though, to discuss this would be to say something like this. Say I have 10 to the negative 1. Because we really don't want to walk away from problems now that we're talking about negative exponents without making our exponents positive. So 10 to the negative 1 then has got to be equal to 1 over 10 to the 1, which is using what we see right up above here. Now, something I will often say is if you have a negative exponent and you want it to stop being negative, then just ship it with its base to the other side of the line. So if I have 10 to the negative 1 over 1, anything really is over 1, and I want to make that a positive exponent, just ship it downstairs, which is really what this is saying. Now, once again, I just want to make a comment with your calculator. If you're confused about negative exponents, say it was, you're just trying to remember, well, what is it with negative exponents? If you put 10 in again and raise that to the negative 1 power and hit enter, 0.1 comes out. Now if you want to make that into a fraction, you can hit math, enter, enter, and hopefully seeing this 10 to the negative 1 and 1/10 will help you remember this whole concept that really all that happens with negative exponents is they just, if you ship the base with its exponent to the other side of the line in the fraction, it will become positive. So following along on that note, it would also be true that 1 over x to the n power would be equal to x to the negative n. Same idea. Oh, hold on a second. Let me write this differently. That is true, but that's basically just restating what I just said. Let me write something different here. Okay. What I want to say is 1 over x to the negative n then has to be equal to x to the n. So if you want to try something with that, then it would be true that 1 over 10 to the negative 1 then better be equal to 10 to the first power. So if I ship this 10 to the negative 1 up, 10 to the first would be equal. So let me just prove that to you on your calculator. here. So 1 divided by 10 raised to the negative 1 power, sure enough, is equal to 10. So let's do some problems with these facts, because it's more about being able to manipulate these facts. So, say we had an example, simplify a to the fourth, b to the negative 3, all over a, b to the negative 2. What does that equal? So I can think of kind of two different ways to do this. So from the last section, the way we would do this is we would say, well, this a really has a 1 on it, and when I'm dividing, I'm going to subtract my exponents, so this would be a to the 4 minus 1, b to, now this is where we got to be a little careful, b to the negative 3 minus a negative 2. And so a to the 4 minus 1 is 3, b to the negative 3 minus a minus is a plus, so negative 3 plus 2 is a negative 1. Now once again, we want to start not walking away from a problem leaving a negative exponent. So in order to make that b to the negative 1 become a positive exponent, just think about this as a fraction. Anything that doesn't look like a fraction really is over the number 1. So I'm going to keep the a cubed on the top, and then I'm going to ship my b to the negative 1 down below, which becomes b to the 1. And normally we would just write this as a cubed over b. Now, another way to think about this problem, I'll come over here with this, is that a to the fourth is all set as it is. A on the bottom, I'll put a little 1 there just to remind you, is all set as it is. If I want to do something right off the bat to get rid of those negative exponents, I can say I'm going to take this b to the negative 3 and ship it downstairs. I'm going to take that b to the negative 2 and ship it upstairs. Now in the end, this doesn't necessarily make the problem any easier, but just getting sort of more comfortable with moving things up and down and knowing what happens to your exponents. Because once again, we get a cubed, b to the negative 1. And then I need to make the same move here to get rid of that negative exponent. Okay, one more example. We'll do a bunch more in class, but just to get you thinking about this. Say you are asked to simplify something like this. 2x to the 0 plus 3x to the negative 3. So now our brains have to be wired to realize that anytime we see anything to the 0, even a million to the 0 power, is really just another way to write the number 1. So 2 times 1 is 2. Now, plus 3 times x to the negative 3. So think of this as a fraction. And so that 3 is going to just stay on the top, because if you want to think about its exponent, it really has a 1 above it. And to write this without a negative exponent, I would ship it downstairs, and that would then become x to the 3rd power. Now, another thing that could be asked would be a question where it says, using this same 2x to the 0 power plus 3x to the negative 3, you could be asked to evaluate when x is equal to some number. It doesn't really matter what the number is. I'll put a 5 in. So what does that mean? It means take 2 times 5 to the 0 power plus 3 times 5 to the negative 3rd power. Now, here's the place we need to be careful. This 2, even though it doesn't have a number above it, really is to the 1st power. So it's not being raised to the 0 power. 5 to the 0 power, just like x to the 0 power, is going to go to the number 1. So this still is just a 2. Plus, and then I come over here, and I could really just do this in my calculator if I want, but just for the purposes of thinking about this, once again, if I want to think about this as a fraction, the 3 is going to stay on the top over 5 cubed. And so in the end, then, I would have 2 plus 3 over 125. And you can either put that in your calc or do the fraction out, and you would get 253 over 125. So, one last comment, and that has to do with something like 2x to the 0 power. I'm just going to go to the next board here. So, 2x to the 0 power is equal to 2 times 1 is equal to 2. 2x in parentheses to the 0 power is equal to 1. Be careful, it's going back to the original exponent laws, because when I have the 2x in parentheses, that's really 2 to the 0, x to the 0. And once again, anything to the 0 power is 1, so that's going to lead to 1. So we just need to be careful about how we're looking at things when they're in exponent, with exponents and fractions in particular. That's it for section 7.2.